Hey everyone, and welcome. We're about to pull back the curtain on this incredible, invisible force that's, well, it's everywhere. Seriously. It's the secret sauce behind some of the fastest tech on the planet, and even the simplest gadget sitting in your house right now. Let's jump in.
All right, so let's kick things off with a bit of a brain teaser. Think about this. On one side, you've got these futuristic maglev trains, right? The ones that literally float and hit insane speeds. And on the other, you've got your doorbell. Super simple. Been around forever. So what in the world could they possibly have in common?
And the answer is electromagnetism. Yep, that one fundamental principle of physics connects a massive high-speed train to that little button on your door. It's just a perfect example of how one simple idea can have a totally massive impact. So what is an electromagnet anyway? Honestly, it's simpler than it sounds. Think of it as a magnet with an on-off switch. When you run an electric current through it, boom, you get a magnetic field. Turn that current off and poof, the magnetic field just vanishes. And that simple on-off trick, that's the secret ingredient to pretty much everything we're about to talk about.
So first up, let's look at how this on-again, off-again magnet has totally changed the way we get around. And I mean everything, from trains that literally fly over their tracks to, maybe the electric car you've got parked outside.
And the applications here are just wow. They're all over the place. You see them in those super fast maglev trains, we'll get to those in a sec, but also in the motors of electric and hybrid cars. They're even the muscle behind those giant cranes you see at shipping ports, lifting tons of metal like it's nothing. This is a tech that scales from absolutely massive to tiny.
Okay, now this is where it gets really cool. The maglev train. How does it pull off its magic trick? Well, first, you've got these super powerful electromagnets on both the train and the track, and they push against each other, repelling, lifting the entire train right off the ground. That's right, no wheels, no friction. Then, to get it moving, another set of electromagnets flips on and off in a super fast sequence, creating this magnetic wave that pushes and pulls the train forward. It's absolutely brilliant.
And the result of all that magnetic wizardry? You get a ride that's unbelievably fast, super quiet, and just silky smooth. It's the perfect showcase of what happens when you use electromagnetism to just get rid of friction altogether. It completely transforms how we travel.
Okay, so we've seen how it moves us around the planet. Now, let's shift gears and see how that exact same invisible force is used in the life-or-death science of modern medicine. It turns out that precise on and off control isn't just for making things go fast, it's for making healthcare safer and way more effective.
I mean, just look at this list for a second. We're talking about giving doctors these incredibly clear images of our insides with MRIs. We're talking about precisely targeting cancer cells in radiation therapy. They're even used to stimulate parts of the brain to help treat things like depression. This technology is, without a doubt, right at the cutting edge of medical innovation.
And this quote really nails why it's so important. MRI machines use these immensely powerful electromagnets to see inside the human body in stunning detail. But here's the kicker. One of the biggest benefits is that it does all this without zapping you with any harmful ionizing radiation, the kind you get from X-rays. That makes it a much, much safer way to see what's going on.
And here, it's all about one thing: precision. In radiation therapy, you can think of electromagnets as these highly skilled guides. They steer beams of energy directly to a tumor while carefully dodging the healthy tissue all around it. That level of pinpoint accuracy can be the difference between a successful treatment and one that comes with really serious side effects.
All right, we've seen the gigantic scale and the life-saving scale. So now, let's bring it all the way home. Let's talk about the silent, hidden workhorses that are buzzing away in the appliances you use every single day, probably without even thinking about it.
Yeah, this is where you might have a few of those "oh wow" moments. Ever wonder what makes the drum in your washing machine spin? That's an electromagnet. The little wires that glow red hot in your coaster or your hairdryer? Yep, electromagnetism at work. And that classic doorbell chime? An electromagnet creates a field to pull a tiny hammer, which then strikes the bell. They are quite literally everywhere. And it doesn't even stop there. Think about pretty much any form of entertainment. In a speaker, an electromagnet turns electrical signals into the sound waves you actually hear. And a microphone, it does the exact opposite. It uses an electromagnet to turn the sound waves of your voice back into electrical signals. It's this perfect, elegant, reversed process, and it powers pretty much all of how we listen and communicate.
All right, for our last section, let's look at what might just be the most mind-blowing application of them all. We've seen electromagnets move trains, heal people, and run our homes. Now let's see how they form the invisible foundation of our entire digital world.
Because, you see, its most vital role
might just be the one you can't see at all. It's operating on a microscopic scale to store every single photo, video, and document you've ever created.
So, deep inside a classic computer hard drive, there's this tiny but incredibly powerful electromagnet that's always working. To save a file, it zips around, magnetizing millions of tiny particles on a spinning disk, creating a unique pattern for every bit of data. Then, when you want to open that file, it does the reverse. It reads those magnetic patterns to pull up your information. Every single byte of data you own relies on this invisible little dance.
So there you have it. From levitating trains to storing our most precious memories, the humble electromagnet is a truly indispensable part of our modern world. It all comes down to that one simple principle: current on, magnet on, current off, magnet off. But that simple idea has unlocked just unbelievable technological frontiers, and it kind of leaves you with one big question, right? As our world gets more and more electric, where is this incredible invisible force going to take us next?